What if something just passed through our solar system that shouldn't exist? What if right now scientists are staring at data that breaks every rule we thought we understood about comets, asteroids, and the objects wandering through space? We'll buckle up because something extraordinary just happened and most people have no idea it occurred. But a small, dark object hurtling through space at 129,000 miles per hour. That's so fast you could circle the entire Earth in 18 minutes. We're talking about a comet, supposedly, a visitor from another star system. But here's where it gets weird. Todo sobre este objeto, desde el momento en que lo detectamos por primera vez, ha sido erróneo. Incomprehensibly, frustratingly, impossibly wrong. The object is called 3E Atlas. It's roughly 5 to 6 kilometers across. Imagine the width of Manhattan from river to river compressed into a ball of ice and rock. It arrived from interstellar space, and when I say it arrived from nowhere, I mean it literally came from beyond our solar system, from the space between stars. Now, we've only ever seen 2 other interstellar visitors before this one in the entire history of human astronomy. Dos, and now we've got a third, but this one is different. This one is making scientists genuinely uncomfortable. Let me paint you a picture of what makes this so strange. When a comet gets close to the sun, something remarkable happens. All that ancient ice, frozen water, and chemicals that have been locked solid for billions of years suddenly starts vaporizing. The sun's radiation heats it up, and the solar wind, this constant stream of particles flowing outward from the sun, physically pushes that material away. The result, a tail, a beautiful, iconic tail streaming away from the sun, visible from Earth, sometimes spectacular enough to be seen with the naked eye. It's basic physics. It's what every comet does. It's what comets have been doing for the entire history of our solar system. 3E Atlas came within 0.9 astronomical units from the sun. That's closer than Earth gets. We're talking about serious heat here. The data from NASA's Jet Propulsion Laboratory showed something remarkable. The comet was being pushed by its own outgassing, the material boiling off its surface with measurable force. Los números eran específicos, very specific. Running the calculations backward using physics and momentum conservation, scientists determined something definitive. This comet lost at least 13% de su masa total durante su paso cercano al Sol. 13%, that's not a gentle evaporation, that's violent, catastrophic outgassing. We're talking about 4,000 millones de toneladas de material, 4,000 millones de toneladas. Think about that number for a moment. That's material being ejected into space in a matter of days. 4,000 millones de toneladas de gas y polvo deberían crear una exhibición absolutamente espectacular. A massive coma surrounding the nucleus, a prominent tail streaming away from the sun, visible debris clouds stretching for millions of kilometers. This is basic physics. This is what happens every single time. So where is it? El 5 de noviembre, 2 observatorios separados publicaron sus imágenes post-perihelion de este objeto, uno en Italia, uno en España. Both photographed the same thing on the same day, and both showed nothing. Well, not nothing. They showed a compact fuzzy sphere, that's it, a small coma, no obvious tail, no massive debris cloud, just a fuzzy ball. The images were clear about the sun's direction. Anti-sun was clearly marked, that's where the tail should be, pushed by solar radiation pressure, that's where 4 billion tons of ejected material should be streaming away from the nucleus at incredible speeds, but there's nothing there. It's as if the material simply vanished. Now, before I go further, let me be honest about something. There are conventional explanations being discussed in the scientific community. Maybe, just maybe, the material ejected during perihelion was primarily gas, not dust, making it harder to see. Gas no esparce la luz de la misma manera que el polvo. Maybe the viewing geometry is wrong and we're looking at the tail from edge on, which would make it appear invisible. Maybe the mass loss calculations are incorrect and less material was actually ejected than the non-gravitational acceleration suggests. These are all reasonable hypotheses. They're being investigated seriously by competent scientists. But here's where it gets uncomfortable. Each of these explanations requires its own set of special circumstances. And when you start stacking special circumstances on top of each other, when you need multiple unlikely things to all be true simultaneously, that's when scientists start paying very close attention. That's when we start asking harder questions because, and this is important, 3E Atlas is anomalous in more than just this one way. This missing tail is the 10th documented irregularity. Hay 9 otros, 9 anomalías anomalías separadas e independientes, each one strange on its own, cada uno requiere su propia explicación. And when you multiply the probabilities together, when you ask what are the chances that all 10 of these unlikely things happen together in the same object, the numbers become genuinely small, menos de uno en 10,000, possibly less than 1 in 100,000, depending on which statistical models you use. Let's talk about what these anomalies actually are, because understanding them is crucial to grasping what we're really dealing with. First anomaly, the trajectory itself. When 3E Atlas was first detected on July 1st, astronomers immediately began calculating its orbit. Dentro de semanas, algo se hizo claro que no debería haber sido claro en absoluto. The comet's path through our solar system is aligned with the ecliptic plane, that's the flat disk where all our planets orbit, to within 5 degrees. Now that might not sound significant. Let me explain why it's actually very, very strange. The ecliptic plane is where everything in our solar system orbits the sun. Earth, Mars, Jupiter, Venus, all the planets move in roughly the same plane, like marbles rolling around the rim of a dinner plate. This makes sense because they all formed from the same spinning disk of dust and gas about 4.6 billion years ago, but 3E Atlas didn't form here. It came from interstellar space, the deep, cold, dark space between stars, and in interstellar space there is no preferred direction. There's no cosmic flat plane that all objects follow, no gravitational reference frame that would push an object to align with our planetary disk. Si un objeto llega desde el espacio interestelar, podría venir de cualquier parte. Arriba, abajo, de lado, diagonal, there's absolutely no reason for it to be aligned with our planetary plane, and yet this one is. Its trajectory is retrograde, meaning it orbits opposite to the planets, but it does so almost precisely within the same plane as all our planets. The probability of this happening by pure chance, 0,2%, 1 en 500. Right there, before we even start looking at what this thing is made of or how it behaves, its arrival path is already statistically unusual. Segundo, anómalo. El chorro hacia el Sol durante julio y agosto de 2025, múltiples observatorios capturaron algo absolutamente sin precedentes. 3E Atlas was shooting a jet of material toward the sun, not away from it, hacia él. Let me be clear, this is not supposed to happen. Comets develop tails that point away from the sun because solar radiation pressure, the physical pressure exerted by photons from the sun, and the solar wind físicamente empuja el gas y el polvo expulsado hacia afuera. It's like trying to blow smoke into a fan. Physics simplemente no permite que la materia fluya hacia el sol y contra esa presión. Now there is a phenomenon called an antitail, an optical illusion, where the viewing geometry makes a comet appear to have a spike pointing toward the sun, but it's not real material. It's just our perspective seeing a curved tail from edge on. Astronomers know how to identify these illusions. They've seen them hundreds of times. The sunward jet from 3E Atlas wasn't an illusion. Multiple research teams analyzed the geometry. They checked the viewing angles from different perspectives. They ran the calculations. This was actual material being ejected toward the sun, defying the radiation pressure that should have pushed it the other way. No conventional comet has ever displayed this behavior. No natural mechanism adequately explains it. This isn't a minor quirk. This is a violation of expected physics. Tercera anomalía, la combinación de masa y velocidad. 3E Atlas has a nucleus about 5 to 6 kilometers wide with a mass estimated at about 30 billion tons. Now compare that to the other interstellar visitors we've detected. Oumuamua, el primero descubierto en 2017, 1 millón de veces menos masivo. Comet Borisov, the second one found in 2019, 1000 veces menos masivo. And remember, 3E Atlas isn't just more massive, it's also moving faster through the solar system than both of those previous visitors. Not ligeramente más rápido, significantly faster. Here's why this matters. In interstellar space, larger objects are statistically rarer than smaller ones. It's basic physics. There's more small debris floating around than large rocks. Fast-moving objects are also rarer than slow ones because ejecting something at high velocity requires more energy. The probability of detecting an interstellar object that is both exceptionally large and exceptionally fast, according to the statistical models, menos de 0,1%, 1 en 1000. We've now observed 3 interstellar objects in our history. The first one was small and relatively slow. El segundo era pequeño y relativamente lento. El tercero ocurre a ser 1000 veces más masivo y moviéndose más rápido que los demás. ¿Es imposible? Número. Is it deeply improbable? Sí Very yes. Cuarto, anómalo, la llegada y los encuentros planetarios. 3E Atlas didn't just pass randomly through our solar system, it passed close to multiple planets with remarkably precise timing. En septiembre voló a decenas de millones de kilómetros de Marte. The European Space Agency's orbiters were in absolutely perfect position to observe it. Then it swung past Venus, then its trajectory brought it near Jupiter. Each encounter was close enough for detailed scientific observation, but not so close as to significantly alter the comet's path through gravitational interaction. Cada encuentro ocurrió cuando los vehículos espaciales estaban presentes y operacionales. And here's the really interesting part. The arrival time was fine-tuned in a way that at perihelion, when the comet was closest to the sun and potentially at its brightest and most active, it was completely unobservable from Earth. The sun was directly between us and the comet, making ground-based observation impossible. It's as if someone planned a tour of the solar system's major observation platforms while avoiding direct visibility from the planet with the most telescopes. The probability of this timing occurring naturally, 0,005%, 5 en 100,000. Statistically, that's essentially asking, what are the odds? Quinto, anómalo, la composición química. When spectroscopic analysis of the comet's coma began in July, something strange appeared immediately. Nickel. Lots of nickel. More nickel than iron, which is extremely unusual. In typical comets, if metals are present at all, iron dominates. The ratio of nickel to iron is well established across thousands of observations. We have a baseline, but 3E Atlas flips this ratio completely. It has more nickel than iron, a pattern seen in industrially produced nickel alloys, not in natural cosmic ice balls formed in distant star systems. Even more striking, the ratio of nickel to cyanide is orders of magnitude higher than any known comet, including Borisov, the previous interstellar comet. Orders of magnitude means we're talking factors of 10, 100, possibly 1,000 times different. This isn't a slight variation, this is a completely different chemical signature, una composición que no debería existir en la naturaleza. The probability of a natural comet displaying this composition por debajo del 1%, that's in the range of statistical anomalies. Sexta anomalía, el agua desaparecida. Comets are supposed to be dirty snowballs, that's the scientific definition. Water ice is their primary component, often making up 70 to 80% of the total mass. When they approach the sun, that ice vaporizes, creating the distinctive coma and tail we associate with comets. It's the water vapor that creates the visible structures. 3E Atlas contiene solo 4% de agua por masa, 4%. That's not a comet, that's barely ice at all. It's more like a rock with a slight frost coating. This contradicts everything we understand about comet formation, whether in our solar system or any other. Comets form in the cold outer regions where water ice is abundant. There's no known formation mechanism that produces comet-sized objects with such low water content, and yet 3E Atlas is classified as a comet because it does show outgassing. Es activo, it's just not active in the way comets should be active. The composition is fundamentally wrong. Es séptimo anómalo, polarización negativa extrema. This one gets a bit technical, but stay with me because it's important. When light reflects off a surface, it becomes polarized, meaning the light waves align in specific directions. The degree and type of polarization tells us about the surface properties, the size and shape of particles, the composition. Every comet ever observed, including the interstellar comet Borisov, shows a consistent polarization signature. Scientists have built detailed models based on thousands of measurements. The patterns are predictable. 3E Atlas muestra una polarización negativa extrema que es inigualada en toda la base de datos de observaciones de cometas, not ligeramente diferente, completamente fuera de los gráficos. The light reflecting from its surface is polarized in a way that doesn't match any natural dust grain models we've developed. The probability of this occurring in a natural comet, por debajo del 1%. Octavo anómalo, la alineación del wow signal. En 1977, un telescopio de radio detectó una potente señal de banda ancha desde el espacio. It lasted 72 seconds, was far stronger than background noise, and appeared to come from the direction of the constellation Sagittarius. The astronomer reviewing the data was so surprised that he circled it and wrote, "Wow!" in the margin. The signal never repeated. Its origin remains completely unexplained to this day. 3E Atlas arrived from a direction in the sky that coincides with the WOW signal to within 9 degrees. Now, is this meaningful? Maybe not. The WOW signal's exact source location was never precisely determined, and 9 degrees is still a fairly large area of sky, about 18 times the width of the full moon. But the probability of random coincidence, 0,6%. 1 en aproximadamente 170. Noveno, anómalo, la inusual luminosidad y color near perihelion 3E Atlas brightened faster than any comet in the entire observational database. Not just más rápido, dramatically faster. The rate of brightening didn't match any existing models of cometary outgassing. Additionally, during this brightening phase, the comet appeared bluer than the sun. Normal comets reflect sunlight, so they appear roughly the same color as the sun, maybe slightly redder due to dust particles. Blue comets are extraordinarily rare because there's no common mechanism that selectively scatters blue light more than red light in typical dust grains. Whatever was causing 3E Atlas to brighten was also causing it to emit or reflect an unusual spectrum. Blue, bright, and fast-changing all at the same time. The probability of this combination, por debajo del 1%. And finally, the 10th anomaly brings us full circle, the missing tail despite massive mass loss. We already covered this, but it bears repeating. The non-gravitational acceleration proves substantial mass loss occurred. The physics is clear, the math is straightforward. 4,000 millones de toneladas de material dejaron la superficie de ese cometa en cuestión de días. Where did it go? Si formaba una cola de polvo típica, la veríamos desde la Tierra. Si formó una cola gaseosa, las observaciones espectroscópicas lo detectarían. Si fragmentó en trozos más grandes, nuestros sistemas de seguimiento habrían detectado esos fragmentos. Instead, we see a compact coma and no clear tail, as if the ejected mass simply vanished from our universe. Now let me be absolutely clear about something crucial. Each of these anomalies, taken individually, has potential conventional explanations. Maybe the trajectory alignment is just luck. Maybe the sunward jet was a short-lived rotational effect. Maybe the composition reflects an unusual formation environment in another star system. Maybe the missing tail is an observational limitation. Maybe the brightness surge was just a particularly active outgassing event. Scientists can theorize explanations for each individual anomaly. That's what science does. We build hypotheses, but here's where it gets genuinely uncomfortable, and this is where the real significance lies. These aren't individual anomalies scattered across different objects. Estos son 10 anomalías simultáneas en el mismo objeto, the same comet, happening together. When you multiply probabilities, when you ask what are the chances that all 10 of these unlikely things happen together in the same comet, the números se hacen muy pequeños. Menos de 1 en 10,000, possibly less than 1 in 100,000, depending on which statistical models you use. This is what's driving serious scientific discussion right now, and I want to emphasize something. This isn't fringe science, this isn't pseudoscience. Multiple independent research teams have confirmed these anomalies. The numbers are public, anyone can verify them. This is where Harvard astrophysicist Avi Loeb has been focusing a lot of his attention recently. Loeb is known for unconventional hypotheses. A few years back, he suggested that Oumuamua might be artificial. Many of his colleagues disagreed with him. Some still do, but his methodology is sound. When something displays multiple independent anomalies, each unlikely on its own, you cannot simply ignore the pattern. That's not how good science works. Loeb isn't claiming 3E Atlas is a spacecraft. He's not saying it's definitely alien technology. He's saying the data doesn't fit natural comet models, and that's worth investigating seriously. Él está llamando para más observaciones, más análisis, más atención a los detalles que nos suman. And importantly, he's not alone anymore in raising these questions. The observation data is public. Other researchers are now running their own analyses. Some agree with Loeb's interpretations, some don't. But everyone agrees the object is unusual, y en ese acuerdo, ese consenso sobre lo extraño es realmente significativo. So what are we actually looking at here? ¿Cuáles son las posibilidades reales? The conventional explanation remains the most likely. 3E Atlas is probably a natural comet from another star system formed under conditions different from anything in our solar system. Maybe it formed around a star with a different chemical composition, explaining the unusual nickel to iron ratio. Maybe it's its parent star system had different temperatures and pressures in the comet-forming regions, explaining the low water content. Maybe we're simply seeing natural phenomena pushed to their statistical extremes, all happening to coincide in one object. Maybe we're just looking at an outlier, the kind of statistical extreme that must exist if you have a large enough sample size. This is the position most scientists hold, and honestly, it's not unreasonable. The universe is vast. Statistical outliers must exist. We've only observed 3 interstellar objects in the entire history of human astronomy. Our sample size is tiny. It would be premature to conclude anything extraordinary based on such limited data. But there's another possibility, uno que es más difícil de discutir en círculos científicos sin ser desestimado o ridiculizado, y aunque los datos siguen sugiriendo que consideremos de todos modos. What if 3E Atlas is not entirely natural, not a spacecraft necessarily, not a probe in the way science fiction imagines, but something diseñado, algo dirigido, algo que sirve un propósito más allá del caminar aleatorio por el cosmos? Think about the trajectory again. It entered our solar system aligned with the ecliptic plane, passed near Mars when multiple spacecraft were present and operational, swung past Venus, came close to Jupiter, all while remaining hidden from Earth-based observation at perihelion. That's either an extraordinary coincidence or an intentional route. Think about the composition. More nickel than iron, orders of magnitude more nickel relative to cyanide than any natural comet. Nickel alloys are what we use in spacecraft construction because of their strength and heat resistance. Is that meaningful? Maybe not, but it's worth noting. Think about the missing water. 4% de contenido en agua hace que este objeto se parezca más a un asteroide que a un cometa. Asteroids are denser, harder, more durable. If you wanted to send something on an interstellar journey lasting millions of years, would you build it from fragile ice that evaporates in the heat of a star, or would you build it from rock and metal that endures? Think about the sunward jet, material ejecting toward the sun against radiation pressure with no clear mechanism to explain it, a menos que el mecanismo no esté gasificando, menos que sea algo más, algo activo, algo controlado. Think about the non-gravitational acceleration without a visible tail. The comet is being pushed by something. We can measure the force precisely. We can calculate its effects, but we can't see what's creating that force. 4,000 millones de toneladas de material está desaparecida, pero no hay campo de escombros. There's no debris cloud. Where did it go? Now, I'm not saying any of this proves artificial origin. I'm saying the pattern is strange enough that we shouldn't dismiss the question out of hand. Science advances by asking uncomfortable questions, by entertaining hypotheses that seem unlikely until the data forces us to take them seriously. That's literally the foundation of scientific progress, and Loeb has been receiving criticism for his willingness to discuss these possibilities. Some colleagues say he's being sensationalist, some say he's damaging his reputation by suggesting interstellar objects might be anything other than natural, but Loeb's response is simple, and frankly, I think he's right. The data is what the data is. Si 10 anomalías independientes aparecen en el mismo objeto, eso no es sensacionalismo. That's observation, that's measurement, that's science. Recientemente algo interesante ocurrió. Loeb recibió un correo electrónico de Chile de un ingeniero eléctrico llamado Dario Villen. This person wrote to thank him, not for being right or wrong about 3E Atlas, but for making the topic accessible. For inspiring people who never thought they'd care about astrophysics to suddenly pay attention. Villen mentioned his 18-year-old daughter who had been unsure about her career path. She's now considering astrophysics because Loeb's analyses of 3E Atlas made the field seem alive, uncertain, full of genuine mysteries rather than settled facts. That's what's valuable about moments like this, not necessarily the answer to whether 3E Atlas is natural or artificial, but the reminder that we don't have all the answers. The universe still surprises us. There are still objects we can't fully explain, and that's genuinely exciting. Right now, as we speak, 3E Atlas is moving away from the sun at over 200,000 kilometers per hour. By December 19th, it will pass about 270 million kilometers from Earth, roughly 700 times the distance from Earth to the Moon. For a few days after that, the most powerful telescopes will have one last chance to observe it in detail. Después de eso, se ha ido. By enero de 2026, 3E Atlas abandonará el sistema solar por completo. It will return to interstellar space, traveling at speeds that will carry it light years away within decades. We will never see it again. No future generation of humans will get another look. This was our one opportunity. Este momento octubre y noviembre de 2025. Eso es, the data we've collected will be analyzed for years, new papers will be published, new interpretations will emerge. Some scientists will argue the anomalies are explicable through conventional means. Others will continue to question whether we're missing something fundamental about what this object really is. But there's a deeper question here, one that goes far beyond 3E Atlas specifically. It's about how we approach the unknown. For most of human history, we assumed Earth was the center of everything. Then we learned we orbit the sun. We assumed our sun was unique. Then we discovered billions of other stars. We assumed planets were rare. Then we found thousands of exoplanets orbiting distant suns. We assumed interstellar objects were theoretical curiosities, things that had to exist in theory, but that we'd probably never detect or study. Then we detected 3 in 8 years. Every single time we've assumed the universe works one way, we've been forced to expand our thinking, and every single time that expansion has been humbling. It reminds us how much we don't know, so when an object arrives from another star system displaying 10 separate anomalies, each individually unlikely, all present simultaneously, what should our response be? Should we force it into existing models because that's intellectually comfortable and safe? Or should we acknowledge that maybe, just maybe, the universe has shown us something we don't yet have the framework to understand? I'm not advocating for belief in alien artifacts. I'm advocating for intellectual honesty. The data from 3E Atlas is strange. That's not opinion, that's measurement. That's the foundation of science. Multiple independent research teams have confirmed the anomalies. The numbers are public. Anyone can verify them. What we do with that strangeness, how we interpret it, that's where the debate begins. And honestly, I think it's a healthy debate. Science isn't about consensus. It's about evidence, analysis, and the willingness to revise our understanding when the data demands it. Here's what we know for certain. 3E Atlas is the most massive interstellar object ever detected. It's moving faster than its predecessors. It has a chemical composition unlike any known comet. Its trajectory through the solar system followed an improbably convenient path for observation by our spacecraft. It displayed a sunward jet that defies conventional physics. It lost at least 13% of its mass at perihelion, but shows no corresponding tail. Here's what we don't know: why. We don't know why any of these things are true. Tenemos hipótesis, some more conventional than others. But we don't have definitive answers. Ya tú sabes qué, that's okay. That's where science lives. En el espacio entre observación y comprensión, that's where discovery happens. The Tianwen-1 images released on November 5th will be studied for years. Those blurry black and white frames captured from Mars orbit at a distance of 18 million miles represent the closest look humanity will ever get at this object. Future researchers will enhance them using algorithms we can barely imagine. They'll analyze them with tools not yet invented. They'll compare them to databases of potentially hundreds of interstellar objects that we haven't discovered yet. They'll search for details we missed on the first pass. Maybe those details will resolve the anomalies. Maybe they'll deepen the mystery. Either way, they matter. 3E Atlas is not the last interstellar object we'll detect. It's the third of many. As our detection systems improve, as our telescopes become more sensitive, as the Vera Rubin Observatory comes online and begins scanning the entire visible sky every few nights, we'll spot more of these visitors passing through our cosmic neighborhood. Conservative estimates suggest we might detect one interstellar object per year. Optimistic estimates are higher. Dentro de una década podríamos tener 10 o 20 en nuestro catálogo. Dentro de 2 décadas, cientos. Each one a visitor from another star system. Each one carrying information about conditions we can't study any other way. Here's what's remarkable about interstellar objects. They're free samples from alien worlds, not alien in the sense of biology or intelligence necessarily, but alien in the literal sense, foreign from elsewhere, formed under different conditions, shaped by different processes, composed of materials that might not exist anywhere in our solar system. Every interstellar object is a messenger. It traveled for millions or billions of years through the void, through temperatures near absolute zero, through radiation fields and gravitational wells, carrying with it the chemical signature of its origin. The story of a star system we'll never visit, and for a brief moment as it passes through our neighborhood, we have the chance to read that story. 3E Atlas es un capítulo, a strange, confusing, provocative chapter that raises more questions than it answers. But it's not the final chapter, it's barely even the introduction. The data we collect now will inform our understanding of future visitors. The anomalies we document will become the basis for new theories. The questions we ask today will shape the research programs of tomorrow, and eventually, as the sample size grows, patterns will emerge. Maybe we'll find that objects like 3E, Atlas are common, that the first three we detected were actually unrepresentative outliers. Maybe we'll find the opposite, that most interstellar visitors are mundane rocks and ice balls, making 3E Atlas even more extraordinary by comparison. We don't know yet, but we will. That's the promise of this new field of astronomy. We're not stuck speculating about what might be out there. We're observing what actually is out there. We're documenting it. We're measuring it. We're arguing about what it means. And sometimes, just sometimes, the data will surprise us. It will show us something we didn't predict, algo que nuestros modelos no pueden explicar fácilmente, algo que nos obliga a expandir nuestra comprensión de lo que es posible. 3E Atlas is exactly that kind of surprise. Whether it turns out to be an exotic natural phenomenon or something more, it's pushed the boundaries of our knowledge. It's made us reconsider assumptions we didn't even know we were making. It's reminded us that the universe is under no obligation to make sense on our terms. There's humility in that realization, a recognition that we're still novices, still learning the basic vocabulary of cosmic phenomena, still building the frameworks we'll need to truly understand what we're seeing. But there's also excitement, because if the universe can surprise us this thoroughly with just 3 interstellar objects, imagine what we'll learn from the next 100. Imagine the discoveries waiting in the next decade, the next generation, the next century. Right now, somewhere in interstellar space, another object is on its way to our solar system. Maybe it's already inside the orbit of Neptuno, undetected because it's too faint or moving at the wrong angle. Maybe it won't arrive for another 10 years or 50 or 1,000, but it's coming. They're all coming. The galaxy is full of these wanderers. Some tiny fraction of them pass through our cosmic neighborhood. Cada llegada es una oportunidad, a chance to learn something new, a chance to test our theories against reality, a chance to be surprised, and maybe, just maybe, one of these objects will be so unusual, so thoroughly anomalous, that it forces us to confront a question we've been dancing around for decades. Estamos solos. That's the subtext running through every discussion of 3E Atlas, every analysis of its chemical composition, every calculation of its trajectory probabilities, every debate about the missing tail, the question we're all thinking about, but most are hesitant to voice. Could this be evidence of something beyond natural processes? Could 10 simultaneous anomalies, each individually unlikely, be a signal rather than noise? I'm not saying it is. I'm saying we should be intellectually prepared for the possibility that someday one of these interstellar visitors might genuinely be artificial, a probe, a messenger, a piece of abandoned technology, algo construido con propósito en lugar de ensamblado por colisiones aleatorias e interacciones gravitacionales. That day might not come in our lifetimes. It might never come at all. The universe might be full of natural wonders and completely empty of artificial ones. And you know what? That would be a valid answer to the question of whether we're alone. But if that day does come, if we do detect something genuinely artificial passing through our solar system, the first step will be recognizing it, and that recognition will come from asking the right questions, from developing the analytical tools to distinguish artificial from natural, from being willing to consider explanations that seem outlandish until the data makes them necessary. 3E Atlas might not be that object, probablemente no es, but it's teaching us how to look, how to analyze, how to think about interstellar visitors as more than just astronomical curiosities. It's training us for whatever comes next, porque algo vendrá después. Otro objeto, another mystery, another dataset that challenges our understanding, and then another, y otro. This is the new normal in astronomy. Interstellar objects are no longer theoretical. They're observable, measurable, analyzable phenomena that we'll encounter regularly for the rest of human civilization. Our children will grow up in a world where interstellar visitors are routine astronomical events. They'll read about 3E Atlas in textbooks. They'll see the Tianwen-1 images in museums. They'll learn about the 10 anomalies that sparked so much debate in 2025. Y quizás entonces tendremos respuestas. Maybe the mystery will be resolved, maybe the anomalies will be explained, maybe the debate will be settled, or maybe not. Maybe 3E Atlas will remain a puzzle, an unsolved riddle from the early days of interstellar object astronomy, the strange comet that broke all the rules and vanished before we could fully understand it. Ocho, it matters that we documented it. It matters that we asked the difficult questions. It matters that we preserve the data for future analysis, because science science is cumulative. Every observation builds on previous observations. Every mystery that remains unsolved today becomes a clue for researchers decades from now, working with better instruments and more complete theories. The Tianwen-1 images, those blurry black and white frames of a fuzzy sphere without a tail, will be studied by scientists who haven't been born yet. They'll enhance the images with algorithms we can't imagine. They'll compare them to databases of hundreds of interstellar objects. They'll see patterns we're currently blind to, and maybe they'll understand what we witnessed in October and November of 2025. Maybe they'll explain why 3E Atlas behaved the way it did, why it displayed so many anomalies, why 4 billion tons of ejected material left no visible trace. Hasta entonces nos sentamos con la incertidumbre. We continue analyzing the data we have, we prepare for the next interstellar visitor, and we remember that the universe is vast, ancient, and strange beyond our current capacity to understand. 3E Atlas came from somewhere, a star system perhaps hundreds of light years away, orbiting a sun we'll never see, formed from materials and conditions we can only infer. It traveled for millions of years through the void, through temperatures near absolute zero, a través de campos de radiación y pozos gravitacionales, carrying with it the chemical signature of its origin. And then, for a few brief months in 2025, it passed through our solar system. It came close to Marte, cerca de Venus, cerca de Jupiter. It approached the sun at 9/10 of an astronomical unit. It experienced extreme heating, violent outgassing, forces that would have destroyed most comets. It lost 13% of its mass in a matter of days, and then it left, accelerated by forces we measured but couldn't see, racing back toward interstellar space at speeds that will carry it light years away within our lifetimes. We got one look, una oportunidad. China's Tianwen-1 captured the closest images we'll ever have. Ground-based telescopes documented its post-perihelion state. Spectroscopes analizó su composición. Mathematicians calculated its trayectoria y aceleración. And now it's over. 3E Atlas is leaving. By the time you hear this, it might already be beyond the orbit of Mars, moving outward, dimming, becoming harder to observe with each passing day. En enero de 2026 cruzará el límite de nuestro sistema solar y regresará al espacio interestelar. It will continue its journey through the galaxy, perhaps for another million years, even perhaps for a billion, until some gravitational interaction alters its path or some catastrophic collision ends its existence. But the data remains, las imágenes, las mediciones, las analíticas espectroscópicas, las calculaciones de trayectoria, all of it preserved, all of it available for future researchers to study, to question, to reinterpret. In light of new discoveries, that's what we do as scientists. We document the universe as best we can, we make measurements, we preserve data, we ask questions, we admit when we don't have answers, and we keep looking, keep observing, keep trying to understand. 3E Atlas has shown us that the universe still has surprises, that our models are incomplete, that 8 years into the era of interstellar object astronomy, we're still learning the basics. Still being caught off guard, still encountering phenomena we didn't predict. Y tú sabes qué? That's exactly where we should be, at the edge of understanding, pushing forward, comfortable con la incertidumbre, excited by mystery, because the alternative, a universe we've already figured out, where nothing surprises us anymore, where every object fits neatly into existing categories, that would be a much smaller universe, a much less interesting cosmos. 3E Atlas nos dio algo mejor. It gave us questions, real, substantial, scientifically valid questions that will drive research for years to come. It gave us data that challenges our assumptions. It gave us a glimpse of how much we still have to learn, and in doing so, it reminded us why we look up at the sky in the first place. Not porque esperamos encontrar respuestas fáciles, but because we're curious about the questions. Not porque el universo nos debe comprensión, but because the pursuit of understanding is what makes us human. So as 3E Atlas fades from our telescopes and returns to the interstellar void, we're left with those questions. 10 anomalías documentadas, un visitante misterioso, and the certainty that more are coming. The next chapter of this story is already being written. Another interstellar object is already on its way. Ya viaja a través de la oscuridad entre estrellas, already carrying its own mysteries and surprises. We just don't know it yet. But we will. We have the telescopes, we have the instruments, We have the curiosity and the determination to keep looking, and when that next visitor arrives, we'll be ready, we'll document it, we'll analyze it, we'll ask the difficult questions, and we'll preserve the data for future generations to study and reinterpret and understand in ways we can't yet imagine. That's the promise of this new era in astronomy. Not answers, but questions. Not certainty, but discovery. Not the end of mystery, but the beginning of understanding. 3E Atlas was strange, anomalous, imprecedentado, and absolutely undeniably real. We witnessed something extraordinary, we documented it, and now we move forward carrying those questions with us, ready for whatever comes next, because in this universe, in this galaxy, at this moment in history, we're finally in a position to see beyond our solar system, to receive visitors from other stars, to study materials and processes that exist nowhere in our local neighborhood, and sometimes those visitors will be strange. They'll break our models, they'll display behaviors we can't explain, they'll force us to expand our thinking. That's not a problem, that's an opportunity. So here's to 3E Atlas, the mysterious visitor from another star, the comet that wasn't quite a comet, the object that lost 13% of its mass but showed no tail, the anomaly that sparked 1,000 debates and will drive research for decades to come. We'll never see it again, but we'll never forget it either. And somewhere out there in the vast darkness between stars, another visitor is on its way. We'll be watching and we'll be ready.